It is known as VNIT Nagpur. He obtained his BTech degree in chemical engineering from LIT Nagpur in 1999 and a PhD in chemical engineering from the same institute in 2008. His research specialization is biomass and waste utilization, biorefinery, sustainable energy, sustainable engineering, and scientific validation of traditional sciences. He is author of around 125 publications and produced 9 PhDs. He also has 7 patents in his name. So he has developed a process of making lightweight and thermal insulating construction material using paper mill waste. His technology of making ultrafine powder neem biopesticide is purchased by 20 plus companies till now. He designed and commissioned a potato peel biorefinery plant, which is the first of its kind globally. His process of on-farm paddy straw digestion to manure is successfully commercialized. He offers consultancy to industries to perform life cycle assessment. He leads R&D projects sponsored by Government of India and private industries. Dr. Mandavgane is the recipient of Fast Track Young Scientist Research Grant by Department of Science and Technology, Government of India. He is the Honorable Governor's nominee to Management Council of Yashwantrao Chauhan Maharashtra Open University, Nasik. He was the Maharashtra State Nodal Officer of AICTE's initiative to support SAGY, that is Sansad Adarsh Gram Yojana. He contributed to Niti Aayog's task force on doubling the farmers' income by developing biorefinery-based agro-business model. He was a special invitee of MHRD's NIT Curriculum Review Committee. He was the National Coordinator for Young Scientist Conclave and Outreach Program under India International Science Festival, that is IISF 2015-19, the largest annual science festival organized by Ministry of Science and Technology, Government of India. So thank you very much, sir, for accepting our invitation and coming here on the online platform. So, sir, you can share your screen and please enlighten us with your expertise. Over to you, Sachin.
Yeah, thank you. Thanks for this invitation and this introduction. And I welcome all for this talk. And I hope that post lunch, this talk will not be as boring as you might be expecting. Right? So we will try to have a kind of interactive session where you can post in the chat box, right? So that I would at least know what exactly your feedback is, what you are thinking about. So uh, what I'm going to do today is a kind of assorted presentation. Assorted presentation means when we go to any sweet shop, we generally ask couple of sweets of one type, another type, and we don't ask only one type. So that is what assorted is. And that is what we are going to do in today's talk also. I will be talking about different technologies which we have developed here in lab with the help of undergraduate students or postgraduate student or PhD scholar, and then finally reach to land. And so I will tell a story for each case, and probably during the presentation or maybe at the end of a presentation, I would expect and I would welcome questions, your queries, right? So the overall work that our group is doing here with PhD scholars, UG, PG student is around the circularity, around utilization of waste, agricultural waste, industrial waste. So we basically perform two types of activity. One is experimental work, product development, process development, and we even do analytical work like life cycle assessment, sustainability index. For example, if I will tell you one story that is pre COVID, and at Delhi airport, there were there was one rack and that rack was typically at one counter for selling snacks. And on the top of that, it was very clearly mentioned that the packaging used here is biodegradable, right? And then I realized that this carbon neutrality, life cycle assessment, carbon footprint, which was to a large extent only remain with the academician or researcher, has now reached to a stage where it is being used for a marketing purpose, right? So then later I come to know that there is altogether a new area of green marketing. In green marketing, you can market your product based on the water footprint, the carbon footprint, sustainability index kind of thing. So I will be talking about that as well. So my focus will be on how alternate raw materials we have used for making different products, how we are working on farm for creating value for the farmers, right? And developing new processes where the biorefinery, I'm going to talk about biorefinery and the fundamentals of that, and the end of life. Let me go through the process, through the presentation, so that you will understand things more clearly. This is what we are doing. We targeted the biomass which has carbon to nitrogen ratio more than 50. Typically, those who might be around NCR, National Capital Region, near Delhi, mostly in the month of November and December, there are headlines in all national news. That is about the high pollution in Delhi and around. Then the burning of stubble in Haryana and Punjab. I belong to Nagpur, which is the cotton belt. Here we have main crop as cotton and paddy. The material like paddy straw, the cotton stack. Cotton stack means if you have seen ever the cotton plant, it has flower and it gets minimum 3 to 4 flowers. Those flowers are plucked and those flowers are nothing but actual cotton. So the crop is for 3 to 3.5 months. After the crop is over, the cotton stack are uprooted, right? But in most of the cases, it is burned because the cotton stack, even the cattles do not eat. Same is the case with the paddy straw, typically in North India. But if you ask me the question about paddy straw in Maharashtra, Vidarbha, or Tamil Nadu, the paddy straw is eaten by cattle. So it is a dry fodder for cattle. Whereas in North India, that is not the case. The reason it is not the case that the paddy straw in North area contains a lot of silica. Since it has high silica content, cattle find it difficult to chew it. So they refrain using paddy straw as a fodder, right? So what we have done, and I'm going to talk about the commercial product that has come up and the story from lab to land, where material like paddy straw, material like cotton stack. If you have ever seen the sugar cane, on the top of the sugar cane there are leaves, and those sugar cane trash are also having carbon to nitrogen ratio more than 50. Then bamboo is extensively used in some part of area, typically northeast area, for furniture purpose. So the dust of bamboo is used for that is also one of the biomass which is having carbon to nitrogen ratio more than 50, right? Now typically if we consider the case of northern India, NCR, National Capital Region, or Punjab, Haryana, they are in cotton and they are in the business of your paddy and wheat. They call it as paddy wheat cycle. So paddy is in Kharif. So by October end or first week of November, when we have Diwali, so the your paddy is harvested. And end of November in Rabbi, they sow wheat. The time gap between these two crops is hardly 3 weeks, right? And that's the reason. So if you do not clean your farm for the next crop of wheat, then you are gone. Therefore, as a farmer, he has a small time gap of 2 to 3 weeks after the end of your paddy and the beginning of your wheat, right? There, the easiest option the farmer has is to burn paddy straw on farm. And of course, because of that, the pollution is taking place, the suspended particulate matter are increasing, the air become difficult even to breathe. So there are so many issues which are related to that. So what we have done is, so when we talk about paddy straw from North India, there are two main challenges. One is it has very high carbon to nitrogen ratio, and second is the time gap between two seasons. So as a farmer, I want a solution such that if you are not allowing me to burn for the sake of environment, then I need a solution for the paddy straw which I can execute on farm within 2 to 3 weeks. Right now, what happens when your material has carbon to nitrogen ratio more than 50, right? So this is what we have come up. I will talk about this. If your carbon to nitrogen ratio is more than 50 or very high, the material doesn't digest fast, right? If you take an example of milk at home, we boil milk at least twice or thrice. Reason is milk has protein. Protein is nothing but nitrogen. If you have nitrogenous material, it degrades very fast. When you have material like paddy straw, where the nitrogen is very less, it doesn't degrade fast, it doesn't digest fast, right? If you have any participant either from Orissa or from West Bengal, you'll find that there are hutments, and that's the area. West Bengal and Orissa is the area which has very high rainfall. Even though they have very heavy rainfall, the hutments, on the top of the hutment, the roof of the hutment is made up of paddy straw. The basic reason is even when it is exposed to such a heavy rain, it doesn't degrade, it doesn't decompose, right? And to digest such a material rapidly in 2 to 3 weeks, that's where we have come up with this product called Bajrang Band. So Bajrang Band is a bioculture which is developed at VNIT. We have this Merino Innovation Center, and Merino is the industry in NCR. They supported this. They have given funds for having this innovation center, and our own student has a startup who is making this culture, and the product is now commercialized. Right? There is a video based on that. I will show. I will just browse. Then we are working on biomass ash. We are working on different fruit peels, the potato, citrus, onion, pomegranate. We generally eat the fruit part of it. and a lot of waste is generated. The peel, the pomace, that goes as waste. So we are trying to make some value out of it. That I'm going to show. And there are a couple of the potato is at commercial level. Citrus is at pilot. It is cross pilot. It is pre-commercial now. And lamb and pomegranate, they are now at pilot. The functional foods we are developing for animals, veterinary people. And the micro neem biopesticide, this is a technology VNIT and BARC has developed, and it has been commercialized and more than 20 people have bought this technology, right? So I will move next. I spoke about this Bajrang Band. I'm going to show you. See, this is the unit which has come up. It's a commercial scale, and daily close to 2 tons of 1 ton of paddy, 1 ton of dry paddy on a daily basis is being composted. So with 40% moisture, close to 1.4 to 1.5 ton of compost is prepared on a daily basis. So you watch this video. It's a short video clip. Please listen to this.
In a laudable industry academic collaborative venture, Merino, along with the Energy and Resource Institute and the Vishweshwaraya National Institute of Technology, Nagpur, has adopted a cost-effective method to convert paddy and other agro-waste into a soil-enriching compost. This is an environmentally friendly alternative to stubble burning. Large quantities of paddy straw is collected from in and around Hapur and stored in sheds. It is then reduced in size by a pulverizer. After this, the shredded and crushed paddy straws are fed into a ribbon tray, where the patented bioculture is sprayed into them and it undergoes dry digestion.
Merino Innovation Center has come up with a unique culture, a biodigester, which digests paddy straw in as less as 3 weeks' time, which otherwise takes 3 months to 6 months. And the product is patented. Not only so, the product has commercialized with a title as Bajrang Band. So Bajrang Band is a very unique decomposer, microbiological consortium, which is used for rapid composting of paddy straw, which we can do as a centralized facility like what we are doing here in Merino on a pilot level. 1 ton of paddy straw on a daily basis is being composted, is being digested, which we are now scaling up to 15 tons per day.
The primary aim of the patented bioculture is to tackle this huge problem of biowaste and its fruitful dispensation. It is aptly named as the Bajrang Band. The mixture is then collected and stored in plastic bags, which themselves act as an anaerobic digester. With the help of the microbes in the Bajrang Band, these shredded paddy straws get decomposed in 21 days and then is an organic manure for agro use. The process is simple, but the result is a remarkable alternative to a major environmental problem. Professor Sachin Mandavgane tells us of the meaningful and valuable collaboration that Vishweshwaraya National Institute of Technology has with Merino Industries.
VNIT, Vishweshwaraya National Institute of Technology, and Merino Industries, we enter into an MOU, and as a part of that, VNIT is having Merino Innovation Center. In that innovation center, we are taking up different projects under the sustainability related topics. The lab work, typically we call it as development of proof of concept. The proof of concept is developed in VNIT laboratories. MTech students, PhD students, even the undergraduate student work on these topics. Once the proof of concept is established,
Then for scaled up study, for a pilot plant study, we come to Merino. So the understanding is following. The basic laboratory work, basic experimental work, which I would be doing maybe in 100 grams or 500 grams of quantity, is done in VNIT. We develop the proof of concept, we develop material balance, energy balance, general understanding. Once that is done, when I have to go for maybe 10 kg, maybe 15 kg, 50 kg of material, we call it as a lab plus experiments. So those lab plus experiments are carried at the Merino campus, where the students who work in the laboratory, they themselves come here. So now they get the exposure of industry, and we carry out the lab plus experiments. Once the lab plus experiment are successful, we go for a pilot plant, where the couple of students are having their PhD topic around this. So they are doing their PhD as well as they are solving a real life problem. So instead of solving an unsolved problem, the students are working on the problem for which the solution is needed.
Right. So this is what this is all about. I mean, this is given the general information about the product and the process, as well as our interaction with the industry. Fine. Now I will move to next. This is another project, and I'm sure people from Rajkot might find this a bit interesting. Reason is, there when we were browsing area around Rajkot and other places, the biomass briquettes, at least biomass briquette machine are made in Rajkot. So the biomass briquettes, once again the agricultural residue which is left over, that is being used as a fuel in furnace. It's a very regular practice. Now the issue is the ash which is coming out from such a kind of boiler and furnaces. This ash is unlike the coal fly ash. Just I will tell you some basic information. The information is following. When the plant grows, during its growth phase of plant, from the sunlight, using the photosynthesis process, it gains the organic part. Whereas from the soil, it takes fertilizers, minerals, and that contributes to the inorganic part. So when we fire this biomass into a furnace or a boiler, the organic part is sacrificed, whereas the inorganic part comes in the biomass ash. So this ash is very rich with the micronutrients, right? So it's very ideal, logical to send that ash back to the soil. So whatever the plant has taken from the soil during its growth phase is sent back to the soil, and we complete the circle, right? But there are challenges while doing so. Any ash, not only this, any ash is highly alkaline in nature. The pH lies somewhere between 9 to 12. It has very high electric conductivity because the inorganic compounds are in their oxide form, right? And since typically the biomass ash that I am referring to, which is used in furnaces and boiler at a temperature of 500 and 600 degrees centigrade, the metal oxides which are available, their metallurgy has totally changed. Though it contains high amount of potash and phosphorus, it's not bioavailable. Now I will just explain you what is the meaning of bioavailable. So if somebody puts wheat grains before me and asks me to eat, I will not be able to eat it nor able to digest it. So I will have to convert it into edible thing. I will have to convert it into chapati, right? So the chapati is something which is bioavailable for me. So though it's basically made up of your grains, but the grains are grounded, then it is cooked, right? And some thermal treatment is given, it becomes chapati, and then I can eat it. Same is the case, though the ash has high amount of potash and phosphorus, close to 5%, 5 to 8% P and K are available, but it is not bioavailable. And now let me tell you that we export potash and phosphorus. We know that plant required fertilizers like NPK. N is supplied with the help of urea. We have huge urea manufacturing. Even in your Gujarat, you have the GNFC, Gujarat Narmada Fertilizer Company. And there are a couple of big companies of fertilizer making. One is in Bharuch also. So there are industries which are in the business of fertilizer. But P and K, what we are doing is we have come up with another product called Angat Band, right? Where what it does, it in fact normalizes the pH and EC, which is biggest problem and challenge. It increases the solubility of P and K. If the solubility of P and K is increased, it only means that its water bioavailability has increased. We are carrying out extensive field trials just to support our lab studies at IARI Delhi. IARI is a very reputed agricultural institute. Just like for engineering, we have these IITs and IICs. Similarly, Indian Agricultural Research Institute Delhi, they are helping us in carrying out field trials for rice and wheat. And local agricultural university here in Nagpur, Punjab Rao Deshmukh Krishi Vidyapit, they are carrying out field trials on marigold and ladyfinger. So ladyfinger means bhendi and marigold means chendu, right? So that is what the trials are. And dosage we found out we need to have 2 tons per hectare. And this project is supported by BRNS. And this is how, so we internally, couple of industries, because there are many industries, they are producing 10 tons of biomass ash per day. Some are producing 1 or 2 tons per ash per day, right? So there is a lot of ash which is generated. There is a serious issue how to handle that ash. So we have come up with this solution. Fine. Now I will talk about the biorefinery. Before we start about biorefinery, I will tell you what is the meaning of biorefinery. Biorefinery is quite analogous to petroleum refinery. In case of petroleum refinery, what happens is we start with one raw material like crude oil. So from the crude oil, we make arrays of products like petrol, diesel, wax, tar, right? So one raw material, and from one raw material, we get different fractions. And that is what the petroleum refinery is. Now, instead of a crude oil as my starting material, if I have a biomass as my starting material, and there also I make arrays of products. See, basically petroleum refinery gives me 3 things which are very important for me. One, it gives me organic chemicals. Second, it gives me energy, right? And third, it gives me polymers. So we cannot imagine a life without polymer. We cannot imagine life without solvent. All process industries require solvent. So solvents are basically derived from your petroleum refinery. So the issue is, can I have a refinery where instead of a crude oil, I'm making use of biomass, right? So here we started using potato. So few of you might be knowing there is one very big brand in Gujarat also about potato wafers that we eat Balaji wafers, right? So I'm going to show you something interesting. So when this potato are processed for any food product, they are first peeled. While doing peeling, either it is machinized peeling or steam peeling. So along with the peel, some starchy material is also come out, right? So for every 1 kg of potato which is peeled, close to 300 to 400 gram is waste because it's a machinized peel. So mechanical peeling is the way that we do at home. As far as the steam peeling is concerned, there the potatoes are exposed to high pressure steam for a few seconds, right? And then the skin, the surface become loose, then it is passed through brush, and the brush just removes the outer surface, right? So what we have done is we started with the pilot of 40 kg of potato peel, and now we have reached to 1.5 tons of wet potato uh, per day. So this is under commissioning. This will be done by maybe in next 2-3 months. I'm going to show you a small video of this. Watch it. Oh, just a moment. I will once again. I will you. Wait. I will tell you something. So this is at Merino Industries Hapur. Hapur is around 60 kilometers from New Delhi. Yeah. Here what we are doing is we are taking that waste potatoes. Waste potato means the peel part. The peel, along with that there is some starchy material. So here in this reactor we remove the starchy material from the peel. And these are the peels. And the starchy material goes to anaerobic digester for biogas. Then these peel are dried in a tray dryer. So it was basically started from lab. Then these are the pilot scale studies which we did there at Merino. Yeah. So presently we are working on oranges. I'm going to show you oranges also. Lab work for apple, pomegranate, tomato, onion also has been done. And lab work for mango, pineapple, papaya is done. Fine. So the products which are the final products of potato biorefinery are nutraceutical. It contains antioxidant, dietary fibers, prebiotics, the the starchy water which goes that makes biogas, and finally the leftover goes in compost. So this the leftover of this and the paddy straw, they are co-digested. And DST funded this project for the initial lab work. On a similar line of potato, this is oranges, the citrus biorefinery. This is a lab level, another is on farm. So on farm I have not included because the pilots are still going on. We could not make a video out of it. You watch this video, you will find it interesting. This is sweet lemon, Mozambique, from street vendor. Dried, then pulverized. We extract oil first. We recover pectin. This is also at Hapur. So initially for the trial, we got this pill free, but then we thought that we should pay some money to the street vendors as well. Yeah. Then coming to the other peels, that is about onions. This is a project which we are doing in collaboration with one farmer producing FPO, farmer producer organization, I think, and they are from Nasi. And you might be knowing that Nasi is the largest producer of onions. So during the season, almost 30 tons to 40, and the people with whom we are working, they have their storages, not cold storage, but they buy from farmers, they store, and then they sell to traders. They help the farmers to get better value for their product. Because of storage, because of many reasons, poor storage, or maybe another reason which I am not aware of, a lot of onions are best. So we are creating, this is this Krushak Mitra Agro Services in Nasik. We see, we are creating value out of valuable products. I will tell you something interesting now. If you go to a market and if you say that I want to compost, nobody is going to ask you what type of compost you want, right? So what now we are trying to create a niche is we are trying to create a sulfur rich compost. Just like we know that there are essential ingredients like NPK, nitrogen, potash, and phosphorus. Now the fourth essential component element for the soil is sulfur. So it is NPKS. So we are trying to create a compost which is sulfur rich using onion, because onion has sulfur. The typical smell that we get of onion is because of the sulfur content. And we are trying to recover quercetin. So if you browse quercetin, almost each of you, including me, you, everybody, has consumed quercetin during this corona period, because that is a well-known antioxidant. Then our pilot trials for pomegranate has started from yesterday only. Once again, once again, Merino is interested in carrying out the pilot trials of pomegranate west. Maybe next time I can show you a video of pomegranate. We'll move to the next technology which is developed and now which has been commercialized. It is micro neem biopesticide. I will show you somewhere. Yeah. So this is a technology which was developed by the support of Bhabha Atomic Research Center. The entire work is done in VNIT, and the technology is being transferred with the help of BAR. Now, what is unique in this? See, as far as the neem is concerned, neem is known as a biopesticide for ages. Even in Sanskrit literature, there are references of neem as a biopesticide. Now, the challenge with the neem is that the key component in the neem is called as azadirachtin. The stability of azadirachtin is an issue of concern because it get it, it degrades fast when it is exposed to sunlight. It degrades fast when mixed with water. But if it is in the natural bounded form, it gives long lasting release and better efficacy. So what we have done is we have created free flowing fine powder of whole neem seed. I'm sure, I know even the Rajkot is known for a neem seed trading. There are many traders in Rajkot. They are in the business of neem because Rajkot Mandi, then in Maharashtra there is a Jalna Mandi, in South there is a Chennai Mandi, and in middle there is a Mandi in Indore as well, right? So neem is known as a biopesticide, there is no doubt. So what we have done is, without extracting oil, we prepared a fine powder of whole neem seed. Since now the azadirachtin is in its natural form, it doesn't degrade. Instead, it gives gradual release, and that's the reason the goodness of neem is achieved, right? And secondly, the fine powder, making a free flowing fine powder of oil containing seed is a challenge. Even at home, you might be knowing that we make chutney, right, of maybe groundnut chutney, or groundnut is, when we try to powder groundnut, since groundnut contains oil, you will not find it's a free flowing powder. Since we are making a free flowing powder and the azadirachtin is in the natural form, its efficacy is extremely high, and that's the reason that technology is one of the most sold technology from BARC, right? And a couple of my students are also in this business, so I'm encouraging my PhD student to have their own startup. So one of my student has startup for Bajrang Baan, another student has a startup for neem based biopesticide as well. So something that they have started at intake reached to actual field. They did some extensive field trials, published papers, and now the product is in the market. Yeah, this is another technology that we have developed. This work was started with undergraduate student. This work, neem work, also started with undergraduate final years work. See, we sell Raddi, the newspaper. For every 1 kg of Raddi, the newspaper that we sell, 850 gram get recycled, and 150 gram is a waste forever. So we converted that into brick. It's an extremely lightweight thermal insulating brick, right? And there was a student in third year who wanted to do some project with me. So I asked him to visit the paper industry around Nagpur and identify a problem. Then he told that there are a lot of landfilling area around the newspaper mill, and that is typically the 150 gram which is not getting recycled is being landfill. So we brought that sample, did extremely detailed analysis, and we found that it contains very high alumina, silicate, and calcium. And so we found that it's a very good material for converting into brick, and we made brick and panels and thermal insulating material. You can find a lot of papers around this, and Indian Express, Times of India, many newspapers, national newspaper have covered this topic. Yeah. Now I will tell you the last part about a startup which has come up. I think Ritesh might be knowing Saurabh Zoglekar, and before that, with him we have started doing this life cycle assessment, and we did a life cycle assessment of close to 2022 industries, uh, and that was a part of a PhD. And then that work we converted into a startup, and I will show you about that. It is suspect solution. So the basic work was done in my lab. It's a PhD work, and now we are offering a life cycle assessment to Godrej, Merino, Chemspec. Where is that? Yeah, Loba Chemicals, Galaxy. So we did, I think, done. Not scrolling. Yeah, Dow. We did. I mean, the startup is offering to Godrej Industries and Godrej Consumables also. So something that we started from lab as a R&D as a PhD work turn up into a full-fledged startup and offering the services in the area of sustainability. Yeah, so these are startups: sustain, create, grow. These are the startups come from lab, and Merino is helping us a lot. There are institute other than VNIT like BARC, IIRI, PDKV. MAPSU is our. They are in Veterinary Sciences University in Nagpur. Even their extension center in Akola, they are helping us for carrying out animal trials, field trials, and funding agencies like DST, BRNS, ACRB, Ministry of Food Processing. They help us in carrying out the lab work. Yeah, thank you. I'm done. I'm open for questions.
Thank you so much. What a wonderful, engaging session for last 1 hour. 61, 62 participants throughout,
Great.
and we have now the session for question answer. If anybody has any question, any comment, any observation, please feel free to shoot. But first observation I would like to make, with your permission, Sachin sir.
Yeah.
If
Go
you,
ahead.
I can see that nowadays the OTT contents have become very engaging for the people to engage on the internet, and to engage for 1 hour, 1.5 hour, how much effort these OTT content prepare, those who prepare, they take. They put the glamour, they put the fight scenes, they put the high adrenaline shots,
Yeah.
scenes, and then also they are not sure whether the audience will be there for 1.5 hour with the content or not. But without having that kind of glamour, that kind of high adrenaline shots and scenes and fight scenes, you have been able to engage all of us for last 1 hour. So it's amazing, exceptional quality, that work you have done and the way you have been taking us to this journey.
Thank you. Thanks a lot.
So let's open the forum if anybody wants to discuss anything. So many things which he had or his team has been doing. We would love to invite you at our campus, sir. Sometimes you should visit and take a physical classroom to our young students and the faculty as well.
I would love to come to Rajkot because we purchase lot many things from Rajkot. We purchase pomegranate peel. There is one vendor who is in the business of only pills. We purchase pomegranate peel, then banana peel from him online through Amazon and Trade India Mart. Then one machine we got for this biomass briquetting, right? And I still remember I came to Rajkot in 2014 to visit Ramakrishna Ashram there, and then from there I went to Junagadh, and I went to couple of places around. I couldn't go to Dwarka though, so you invite, so I will go to Dwarka.
For sure,
Yes.
sir.
Yeah, it will be great privilege. We'll go Dwarka, we'll go to Somnath, we'll
Yeah, I
go
had been to Somnath. Yeah, that's what. Somnath I had been. Right.
and we'll climb the 10,000 steps of Girnar also.
I couldn't climb. I just climbed 10 and then I go there only. Because they told me that it took 3.5 hours to climb.
That's wonderful, wonderful. Great session.
So right now we have ropeway. So don't worry about that. We'll go by ropeway.
there is no fun in going by ropeway. There is a fun going by climbing it.
Yes, in fact, I am the live example. I climbed all the way till Dattatreya, and then when I reached Ambaji, I was completely. I had given that no more. Now I'll go back. But we were in group, and they pushed me so hard that I could go up till Dattatreya. So that's true what you are saying, sir. The real
So
real
you
enjoyment
took
is
three
there
and a
in
half hours?
climbing.
Did you take 3.5 hours or less or more?
I think we started in the morning at 4:30. By
Oh my God.
8:30 we were there. 3 hours, 3.5 hours we took.
Yeah. Yeah, there are a couple of questions now.
Let's take some questions. If you can see the question answer or chat box, please read those
Yes.
questions.
Also,
There is
I'm reading the chat box. Yeah.
okay. Yashvi Modi, if you want to unmute, please let us know if you want to directly contact with sir during this session. So you may raise your hand so we may unmute yourself to better understand your question. Please try to unmute Yashvi Modi if you want.
Yes, sir. Good
Yes.
afternoon to all.
Good afternoon.
Yeah.
Yes. So, sir, as you mentioned that there are many FPOs which are running in Nasik. All right. So, basically, my PhD topic is an interdisciplinary one. Like, I am engaging agriculture with management. Like, you can say agri management. And when you told about the products, so like, do you source that from the farmers or from the cluster of farmers? Like, can I know?
Yashvi, I am not aware what those people are doing, but I can connect you with the Krushak Mitra because
Okay.
they approach to us with a very specific problem, Krushak Mitra Agro. So they
Okay.
approach to us with a very specific problem that they are having a lot of onion waste and how that waste onion can fetch some value for the farmers. But I'm not aware about their business model, whether they are in the contract farming or whether they are in this cluster based farming. So
Okay.
that I
Okay.
am not aware.
Okay. So I would like connect with them and I
So
can
you
know.
write to me, you write one email to me so that I can forward your email to the concerned people and you can directly contact them.
Yes, for sure, sir. For sure. And sir,
Okay.
really, your session was great. I
Thank you.
like the technologies and the innovation which you did was really magnanimous. I literally loved that and would be happy if I can be of any help in your domain.
I mean, you find out how you can contribute. We
Yes,
welcome
for
because
sure.
I know that it. I mean, it's a joint work. Students are working. Everybody is working. We have to contribute in some or the other way. So
Yes,
you only ask that are you giving it to the farmers? So you help us reaching out to the farmers in Gujarat. We would be
yes,
more than
sir.
happy to do that. I can
Yes,
connect my student who has a startup. He will be in touch with you.
yes, sir, sure. I do have 5,000 plus farmers database in all over Gujarat and 100 FPOs. So, like, I would be of great help if you need any point of time. I would mail you and would reach you via there.
Sure.
Sure,
Thank
sir.
you.
Thank you, sir.
Thank you.
Yeah, Tapan sir is he's saying indeed it is an excellent work. Yeah,
Thank you.
I just would like to start with the journey from where sir has started actually. He's the person who used to go to his college by bicycle and now he's running lot of ventures. And in 2014, if I'm not wrong, when the people they were not aware about the technology, how to deal with the labs, he is the person, Professor Sachin Mandavgane, who deal with the technology, who asks the students not in the lab, go outside, do your experiments, record it, and bring it to me.
Yeah.
He never restricted students in the lab itself, and his timing also not restricted. Even if I'm not wrong, somewhere in VNIT early in the morning, somebody used to come to take astrology classes, sir. If I'm not wrong, director 2012 or 11.
Yes.
Early in the
Professor-
morning, 6.
Professor Gokhale, SS Gokhale.
Yes, 7 early in the morning, 7 or 8 class, if I'm not wrong, in the chemical engineering department.
Yes.
He's the person who used to sit there early in the morning.
Yeah.
And he deals with a lot of ventures like gaushalas and everywhere. And I know his enthusiasm. He used to come early in the morning to the laboratories, his cabin. He used to sit there with the students, and he never say no to anyone to meet him. Even when I used to go to Nagpur, sometimes he will ask me just wait for 2 minutes, and then immediately after 30 seconds he will drop a message, please come inside. So he is having that eager to meet each and everyone. So Yashvi, I think that will be a good opportunity for you to discuss with sir and his students as well. Even I'm also his one of student, but not up to the mark right now in terms of research. But yes, still we'll collaborate and we'll try to work, sir.
Yeah. So I will just add what Ritesh was talking about. So one of my student is working on Goshala management. So that's typically I have not included in this presentation. I will next time I will include. So we are working on the small dairy farm. The dairy farm where the number of cattle are less than 15 to 20, right? Small dairy farms. So farmers are not having organized one, very unorganized. So, and typically the area which is rain shade area where there is not too much of rain and the farmers cannot depend on agricultural produce, they mostly depend on cattle rearing. And so 70% of the total milk which is produced in India, and you witness this Anand and Amul revolution, there 70% of the milk comes from the unorganized sector, the small dairy farms, right? They We are coming up with a module where we found that typically in Uttar Pradesh, where slaughtering the your unrecognized slaughterhouses are closed, right? The farmers, we are creating an economical model around the milking and non-milking cows, exclusively for small dairy farms. And we have one case study again in Uttar Pradesh where we use the management and engineering practices in a way the farmer will understand, in an easy to do, easy to execute way, and we could transform a less economically viable or less profit to more profit Goshala, right? And that is what another startup which is coming up, we are targeting only and only small dairy farmers in the form of a small app. It is everything is done. We are carrying out the trials in some part of India. And about one course, I will tell you about other students, other people, about a course called Innovative Design. I will just share one YouTube channel with you, and it's about innovative design. I asked, this is for undergraduate student, and I asked student to go to field outside classroom and search for a problem statement. And it's a course on just a moment, innovative design. Where I should
Share your screen, sir. It is not visible.
no, I'm just still searching it. You search for students innovate. Participant can search for students innovate. VNIT. And just a moment, I will share.
There is a channel called Students Innovate by VNIT.
Yeah. Students innovate plus VNIT. You will find this YouTube channel, and this is of course pre your Corona. so we couldn't do anything. But visit to actual field is a part of the course. And during the course, student has, this is a project-based course, and after the course, during the course, student has to perform one project, and all those projects are now uploaded on the YouTube, because the submission is not merely a hard copy, but student should make one video, and that video he must post on the YouTube.
I can see the value of the problem which you had discussed just now, the Goshala management and also the Uttar Pradesh. I can see this Goshala and Go has become the problem statement for not only common men, for the government also. Now the government can lose the government or they can form the government if they solve this problem. So what a fantastic problem you have taken and you are taking it forward, sir. It's amazing. Great work.
Anything else, or else we can stop?
Anybody else has any observation, any comment, any question, please feel free. Otherwise, we'll wind up in next 5 minutes.
Sir, I would like to give some glimpse, Dhananjay sir, if I can.
Please go ahead, sir.
Yeah, Sachin sir, we have started today morning with the inaugural keynote speech by our provost, Professor Dr. Sandeep Sancheti sir, and he's looking for technologies where teaching learning techniques can be involved in terms of NEP. So he gave keynote speech, and after that we had a session by Pratima Khandelwal ma'am, how to engage the students or what is NEP and all these things. After that, we had one session from our own Dean of Academic Affairs, Professor Sridharan. He discussed about this because the participant may think like that whatever you discussed, it is a kind of application what we discussed a session before it. Kickstart your research. So he demonstrated how to go with the literature, which kind of things we should put in our research article. And you demonstrated what PhD scholars can do, because right now we are targeting the PhD scholars only, mostly PhD scholars and many students from UG or PG final year. So right now, even here in Marwadi University also, we are looking for the open-ended projects, or we have kind of chemical engineering society course where students are motivated, like what you used to do, go to the field, bring the problem statement and try to work on it. So this is the kind of work which we are also trying to work on it under the leadership of our dynamic leadership, like Professor Sandeep Sancheti sir, our deans, Jadeja sir, and other dean and directors as well. So I think for our students, it is a kind of a path on which we can work. I know there was crucial time last 2.5 years. So right now we have all the ways to work on all problem statements, and even right now you are also free to guide us as well, because if you can remember, we had a discussion that I have invited you here in the Rajkot as well. So yes, definitely you have to be here in this year, sir, itself. So please plan accordingly. We will have your session here to guide and enlighten our students and our faculty members as well.
My pleasure. Sure, I will.
We may request to share your slide deck also, because we need to, at the end of this session, 5 days, we have to share with the participants also. So
I will share.
Any other resource if you want to share, we need to. Thank you so much, sir, for accepting our request and sharing such a wonderful session, and lot of seeds you have actually sprouted now or planted in the mind of students, those who are joining here, because students here in Rajkot are very entrepreneurial. So neem and then these oranges peel, this entire thing has picked up, got my attention, that it can also be so valuable for research and creating a value proposition to the society. So you have given a lot of insights in those areas also. Students can start thinking and connecting with you as well, which I can see Yashvi, how much enthusiasm she has to connect with you. So that spark you have created in the heart of the audience today in this call.
Sir, there is one comment from Shaheda. She's saying, really great, sir. We are working on solar energy systems. Tulsi oil and biomass to produce fuels. This lecture makes us more more inspired. Thank you, sir.
Thank you.
Any other comments from the participants? We have 15 more minutes if you want to discuss with the sir. Sir is here. Otherwise, you may write to sir directly, or you can contact to me or Dhananjay sir. So we will contact to sir as well, Sachin sir. Over to you, Dhananjay sir.
So wonderful session. Tomorrow's session, let me share the
So can I leave?
Sir, please unmute yourself. Dhananjay sir.
yeah.
Please unmute.
Thank you so much, sir. So
Yeah, thank you. You make announcement for tomorrow and allow me to leave. Thank you.
Sure. Thank you so much, sir. So for the participants, the link will remain same, and tomorrow's schedule, let me share with all of you that this is tomorrow's schedule, which is there on your screen tomorrow morning. Tomorrow morning, we will have Dr. Professor Rajendra Kumar Joshi. The title is Research in Teaching. Many times what happens, teachers, those who are teaching, they are teaching, and those who are researchers, those who are researchers. So we would like to blend both. Can research be in teaching? So tomorrow, a wonderful speaker. He has been earlier with Wipro Mission 10X from Bangalore, Professor Dr. Rajendra Kumar Joshi. He will be joining tomorrow morning sharp at 10:30. Please mark 10:30. Today it was 10 o'clock because we had inaugural session delivered by our provost, but tomorrow onwards 10:30. Yeah, so sharp 10:29. Let's be all together and inform others also, those who have not joined today. Let us make this wonderful community. And the second session would be of Dr. Deepak Mashru. He will be talking about advanced pedagogy, transforming education through technology. So use of technology in transferring the learning from one side to other side. That will be the area for Dr. Deepak Mashru. And the last session would be Dr. Amrut Mule, and that would be scientific writing and research journey. So what a wonderful panel we have for all of you. So please join tomorrow sharp at 10:29. With these words, we would conclude the day for today. Thank you very much. Have a great evening ahead, and have a great Mahashivratri in the night today. Thank you so much. Over to Ritesh sir if you have anything, otherwise we'll conclude and we'll wind up, call it a day.
Thank you very much, everyone, all the participants for your time. We are waiting for your active participation in the remaining 3 to 4 days as well, where you will find out